Okay, let's look at this 2017 question. This is a very good question because they test everything. There's similar triangles, and then got similar triangles means you have corresponding length ratio, corresponding area ratio, right? So let's see this. This is a parallelogram. So this is 2p, this is also 2p. Can we just label here? Okay, can I just label this one as same direction, okay? So 2p. That means this whole thing is also 3q. Then important thing is AR to RD, 2 is to 1. So if I'm going to split this one up, the whole thing is 3Q, right? So that means this one is Q, okay? And then this one here is 2Q. Easy, right? Okay, so now they want us to find RC. Okay, I'm going to just join it. So RC is here. Okay, I think RC quite manageable for me since I already labeled everything nicely. So what I have, this is part I. So my RC is RD, which is Q, then plus 2P. Is this only worth 1 mark? I believe so. Quite straightforward. 1 mark only lah. Okay? Okay. Oh wait, this is part A, sorry. Okay, so this is part A. So now we have part B. Okay, S is a point on AD, so somewhere here, such that RC equals to 2ST. What does this tell you? So the moment I see this, right, that means I will know that RC is parallel to ST because this is my collinear. Sorry, not collinear, my scalar multiple. Okay, so RCST. So what is it though? S is a point on AD and then T is a point. So they are like one is on AD and then one is on CD. So for it to be collinear, right, then it has to be somewhere along here. It cannot be outside because like that, then not parallel already, ma. So what I have to do is I have to draw another line inside. So I'm just going to draw randomly like that. But I know that these lines are parallel. Okay, so these two are parallel because RC is parallel to what's the other line? ST. So I'm going to label S is on AD, right? So S is here, and then T is over here. So can see my parallel lines. Okay, cannot my S cannot be here because if they die, I'll have my T here. How to parallel like that? Cannot what, right? So the important thing now is you should be able to see similar triangles. Okay, so what you're going to do is we're going to do our similar triangles first. I mean, they're so nice because they already tell me I need to show that it's similar, right? So this is the one that is like that one. Okay, so we got common angle and corresponding angle. So I'm going to start with angle SDT is equals to angle RDC. Remember, don't think so much. Just follow here. SDT, RDC. What's the reason for this one? Not shared, ah. This is my common angle. Okay, then after that, I will have angles TSD, which is TSD will be angle CRD. What's the reason? This one? Corresponding. Okay, so then for this one, good enough already lah. So you can have triangle RCD is similar to triangle STD. What's the reason? By AA. Okay, for similar, my priority is always by AA. So anyway, you know that they are similar, you must know that their corresponding length ratio same. Their area ratio, you're going to square the length ratio. Okay? Oh, 来了. Okay, so now you need this one here. Okay, so we have part 2 already. So you got, when you want to see area, right? Your area will be talking about what? Your areas will be talking about number one, common height triangles. Okay, need to go back to the basics again. Okay, this video I won't spend too much time explaining. So base area, sorry, area I'm talking about area ratio, common height, and similar triangles. Okay, so what they want? They want triangle STD, this small teeny weeny one, to the whole parallelogram. Okay, the small one to the big one from there. So what we have here is that we got this one, RC, right? And then ST is, RC is equal to ST. So if RC to ST, you swap 2 is to 1. So you can see that, okay, my length ratio here, this one 2 units, this one 1 unit. So all your length here is all 2 is to 1, 2 is to 1, 2 is to 1. Okay? Okay, so what we're going to do now is we're going to compare this one, these two first. Alright? Since they are similar triangles, right? So I'm going to square my length ratio. So triangle RCD, wait, I do the small one on top. Triangle STD over triangle RCD. Okay, they are similar triangles, right? So since they are similar triangles, you're going to square the length ratio. Okay, so what we understand is that when I square the length ratio, this is 1 over 4. Okay, so you have your 1 unit here and then the whole thing 4 unit. Do you think I can squeeze this in here? Okay, so this is 1 unit, this is 3 units because the whole thing is 4 ma, correct? Okay, so now, right, you need the whole thing. But the tricky part is, what's the whole thing? Cannot see. So what I'm going to do is I'm going to calculate half my parallelogram. So when I do half my parallelogram, what am I comparing? I'm comparing triangle RDC to triangle ARC. Okay, so wait, where is this? So RDC is here, then ARC is this one. Can see they side by side or not? So common height, right? So their length ratio is 1 is to 2. So that means their area ratio is also 1 is to 2. But what you must realize is that, right? This is 4 units. So make it 4. Okay, so 4 over 8. So that means I will know that, okay, this part here is 8 units. So that means here is how many units? 8 plus 3 plus 1, that's 12 ma. So 12, that means the entire parallelogram is times 2. So if now you want to answer, right, your triangle STD to your whole parallelogram, okay? So parallelogram is ABCD, right? Okay, STD is just 1, right? But parallelogram, half of it was 12, correct? So 12 times 2 will be 24. So they want ratio lah. So you do as 1 is to 24. You saw how we need to link everything together? I also don't know how many marks this. I cannot remember, but I think at least 3 marks. Alright, so must know. So you see, they sometimes it's not as obvious as, I tell you, collinear leh, go and show. They can say, I give you the scalar, then you better know that they are parallel. You better know that you can use your parallel, then you know your similar triangles from there lah. Okay, okay, last part. So for part 3, Q, again, Q is a point on BC. Okay, so now we have congruent triangle. Wow, what is congruent? Congruent, that means they're exactly the same. So if they're exactly the same, then what we have here is that Q is a point on BC. Is congruent to RCD. Where's RCD? Okay, let me just highlight this, okay? So RCD is here. Okay, so they say, what's the triangle? QAB. So the AB is here, right? That means your Q must be where? Your Q must be like, uh, I guess it must be like somewhere here, because Q is lying on BC ma. So it's like that lah. So these two triangles are congruent. So these two highlighted triangles are congruent already. Okay, that means they must be exactly the same. So if they're exactly the same, right? What happens here is that you see this part here is Q, right? So that means this part here is also Q. So what they want us to do, wait, this one is big letter Q. Okay, ABQ. So you want to find QR. So QR is where? QR is this random line here. So how do you find QR? So QR will be QA and then AR. So we need to find QA first, right? Okay, so QA will be, careful your direction. QA will be like that, then like that. So minus Q minus 2P. Okay, remember to put your curly line below. Then now you just need QR. So QR will be QA AR. Okay, so QA is this one. And then AR is 2P. So then at the end of the day, oh, wait, minus 2P, wait, 2Q, sorry, 2Q, right? AR is 2Q, right? Okay, so here will be Q minus 2P. Okay, so this is what we have.